Okay, in this next video, we're going to talk about division of fractions and simplifying fractions. And so some of you have probably seen that we don't ever divide fractions. We really just multiply by the reciprocal. We keep the first fraction the same, we change the division to multiplication, and then we reciprocate the second fraction. Remember, we flip it. And then once it turns into a multiplication problem, we can simply use our rules for multiplication, where we multiply across the numerators and we multiply across the denominators. Some of you might be thinking about why that works or how that works. Well, I found a cool YouTube video that kind of gives you a neat visual representation of why dividing fractions is really the same thing as multiplying by the reciprocal. Kind of cool to see and really understand why it works. So take a few minutes and watch that video before I move on to just purely using the algorithm of multiplying by the reciprocal. Let's go ahead and do that algorithm now in example number 5. It asks us to divide 1/2 divided by 3/5. Well, as soon as I see that division, I know that dividing fractions is really the same thing as multiplying by the reciprocal. Remember, we keep the first fraction the same, we change the division to multiplication, and then we flip the second fraction. So instead of 3/5, I can say I'm multiplying by 5/3. Now that I have a multiplication problem, we don't need a common denominator. We just simply multiply across the tops and multiply across the bottoms. So 1 times 5 is 5, and 2 times 3 is 6. So 1/2 divided by 3/5 is really 5/6. Do the same thing with b. If I have 3/4 divided by 5/7, instead of dividing fractions, I can really multiply by the reciprocal, or maybe you've heard of keep, change, flip, or flip the guy and multiply. Whatever kind of silly things help you remember the different rules. But I'm going to multiply by the reciprocal. I'm going to keep the first fraction, I'm going to change division to multiplication, and I'm going to flip that second fraction. I'm going to multiply across the numerators and multiply across the denominators. 3 times 7 is 21, and 4 times 5 is 20. So 3/4 divided by 5/7 is really 21/20. All right, the next thing we're going to do is talk about simplifying or reducing fractions, because we really always want our final answer to be as simplified as possible, in the smallest possible, nicest version as possible. And if you think of reducing fractions, you can kind of think of two pictures that are equivalent, but broken down into different pieces. For example, if I have 2/4, isn't that the same thing as having 1/2? So instead of breaking it down into 4 pieces, I can reduce that by 2. And really, I have 1/2. So 2/4 is the same thing as having 1/2. I can reduce by a factor of 2, both the numerator and the denominator by a factor of 2. Okay? So let's kind of do some examples of that. If you look at example number 6, it asks us to simplify the fraction 15/40. What we want to do is see if we can break down this fraction into a smaller version of itself. So can we figure out what factors are the same factor of 15 and 40? What number divides into 15 and also divides into 40? How much can we reduce it by? Well, I noticed that 5 goes into 15 and 5 goes into 40. So can I reduce or divide both the numerator and denominator by 5, reducing it down? 5 divided into 15 is 3, and 5 divided into 40 is 8. 3/8 has no other common factors, 3 and 8, so that would be my final answer. 15/40 is the same thing as 3/8. Another way you can think about it is taking that 15 and writing it into different factors, and taking the 40 and writing it into different factors, and seeing if they have a common factor that we can reduce by. Let me show you an example. If I take 15, I can really say that 15 is the same thing as 5 times 3. And I can say that 40 is the same thing as 5 times 8. And then I notice that they both have a common factor of 5. So I can reduce a 5 from the numerator and a 5 from the denominator. Because they both have factors of 5, I can reduce both of them by 5. When I do that, I'm left with 3/8, which is the same thing that we got before. But be careful, that only works when you're talking about multiplication, factors of, not addition or subtraction. So look at B. If I have 36/24 and I want to reduce, is there a factor of 36 that's also a factor of 24? Can I reduce both of them by a certain amount? The first number I thought of is 6, so I divided both the numerator and the denominator by 6. That left me with 6/4. But I noticed that 6 and 4 also have a common factor that can be reduced into both of those. Can't 2 divide into 6 and 2 divide into 4? So I'm going to reduce it again, both of the numerator and denominator, by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. So 36 over 24 actually reduces all the way down to 3 over 2. Now, if you didn't notice the 6, you maybe started with I don't know, a 2 or a 3, and that's okay as long as you keep dividing by factors until you get down to numbers that don't have any common factors, like 3 over 2. Or maybe you noticed right away that they're both, the numerator and denominator, 36 and 24, are divisible by 12, and maybe you reduced them by 12 right away. That's fine too. But no matter what, we should always be able to reduce it down to the same fraction of 3/2. Or you can think of them as factors. You could take 36 and break it down into 3 times 12, and then you can take 24 and break it into 2 times 12. And since they both have common factors of 12, we can reduce, leaving us with 3/2. But again, that only works if you have multiplication, so be careful with that. All right, last one, C. If I have 9 over 72, is there a factor that goes into 9 and goes into 72? Well, I notice they're both divisible by 9. So I'm going to divide both the numerator and the denominator by 9 to keep that balanced. 9 divided by 9 is 1. 72 divided by 9 is 8. So 9 over 72 is the same thing as 1/8. Or again, you can think of factors. 9 times 1 is 9, and 9 times 8 is 72. And since they both have a common factor of 9, we can reduce it, and we're left with 1/8. Now be careful. This does not work if you have an addition sign connecting your two terms. So 2 plus 3 over 2, those 2's cannot cancel. If you really think about that, 2 plus 3 is really 5 over 2. And we know that 5 over 2 doesn't have a common factor, so that can't be reduced. So you cannot reduce those 2's from the numerator and denominator unless every single term can be reduced by 2. Same idea with this second one. 4 minus 1 over 4 minus 2. Those 4's cannot be reduced. Because there's a plus or minus sign connecting those two terms, you cannot reduce them. You can only do it if it's multiplication. Really, 4 minus 1 is 3, and 4 minus 2 is 2. 3/2 we know cannot be reduced. Same thing with this 15 over 54. I've seen students take the 15 over 54 and see 5's on the top and 5's on the bottom, and they just try to reduce those. Unfortunately, you can't do that. What we have to think about is factors of 15 and 54. For example, 5 times 3 is 15, and 18 times 3 is 54. And if they have a common factor, multiples of, then we can reduce. But we can't just reduce pieces out of those numbers. Okay, so be careful with all of those different simplifying techniques. Make sure that you find a common factor of, multiply, and make sure that all of your answers from now on are simplified into the smallest possible version of itself.